We're not gonna have a quiz today because of the snow day last time and the fact that the schedule's all messed up. And I'm really impressed with the fact that people pretty much got the homework done despite that. We are in this class, the assignment on inverse functions. I'll be making adjustments as soon as I figure out how. It's a mess making adjustments between this class and the distance class, because I can't really give an assignment in the distance class that I would give in this class, since they don't have immediate access to the videos. Not that a lot of them are even looking at the videos, but not at all. Okay. And some of them are doing fine. I mean, open math stuff seems to be doing okay for them. Let's see how the first test works out. Okay, anyhow, that's the situation. But right now, we'll concentrate on inverse functions. So, if I sketch, the easiest graph to sketch quickly is the exponential graph. And it's got an inverse function. I'm just doing this from x equals 2 to x equals 2, y equals 0 to y equals 4. So now f of x equals 2 to the x. And the table is very easy to select. Using x values -2, -1, -1, -0, whatever else I thought. Okay. At x equals -2, we have 1/4. At x equals -1, we have 1/2. At x equals 1/2, now we can compute it approximately, but I'll say can't compute. You have no idea how to do that. You don't know Taylor's expansion, and it's your fault for not having had a good year of calculus. Okay. So yeah, seriously, no fault of yours at all. And if we can't compute it, we don't use it. Open math does. I don't disagree with them on that. But what I disagree with is their use of a calculator when you need to know how to calculate these things. Okay. We just say, take a calculator, and now you got your graph. Now you're missing an important step like the arithmetic. Okay. And I take it even further. I do a construction before we ever put numbers on it, right? Because construction allows you to draw the graph pretty accurately and very quickly. Okay, so anyhow, there's a function. Okay, now it's very easy to make a table for the inverse function. The inverse of f of x equals 2 to the x has a table that you can just make. Once you have this table, you just reverse the columns. The y column becomes the x column. So the y column is 1/4, 1/2. And I'm just going to go 1, 2, 4, because since we can't compute these y values, we don't include them on this graph, and we don't need them. You get a very well-defined smooth curve that really doesn't need those -1/2 and 1/2 points. For power functions, you do need those points. Otherwise, you do what open math does and totally screw up the graph of the cubic function, which they did in a very egregious manner. But don't blame the guy that did that. Everybody has their brain freeze up every once in a while and does something careless. Okay. And other than that, I'll show you what that is when we do the cubic function. Okay. very important characteristic of that function that he just screws up terribly, completely. Functions this speed when it should be this speed. Okay. Anyhow, so our y's become x's and our x's become y's, as you probably expect. So here are two functions. This table represents the exponential function on the interval from -2 to 2. This one represents the inverse of that function on an interval that goes from 1/4 to 4. Okay. Now, if you want to make a graph of that inverse, you're going to need something that I didn't draw. You're going to need a 4x4 square or rectangle. You make the squares rectangular as you like, depending on the scale of the thing you're looking at. But in this case, it's going to go from x equals 0 to x equals 4. Okay. Your range here, well, your y coordinates go from 0 to 4. So now your x coordinates are going to go from 0 to 4. Now we don't have a y coordinate for x equals. We don't have an x coordinate for y equals 0, but we're not going to worry about that. We'll see how that works out. Okay, and y is going to go from -2 to 2. There's a red dot. The red dot is right here. So when we subdivide this rectangle, what we're going to do is we're going to divide the x's the way we divided the y's. In other words, we're going to go to the middle and then halfway to the middle from each end, because the x's will become the y's. Okay, so if we want to locate these points, that's our construction. Then the y's are going to become the x's, and we're going to do this with the y's. We're going to subdivide it just like we would we're going to divide the x's up the way we would divide the y's with horizontal lines. But those horizontal lines will become vertical. Same thing. Okay, and the red dot ends up here. And you can kind of think of just taking this rectangle here and just flipping it over. It's actually not what you do. You flip it over and then you turn it inside out. But it's not going to make a difference until you draw the function. Okay. So if you just take this rectangle and do with the vertical what you did with the horizontal, and with the horizontal what you do with the vertical, you got to, okay. Now, if you're in the distance section, you don't have to do these subdivisions. You can scale the graph any way you wish, but you want to be able to get these points. And of course, all the math shows you how to do that. Okay, so now 1/4 -2. Well, x is 1/4 here, and y is -2. So we get this point. And then we get the point 1/2 -1. Well, here's 1/2. And here's -1. Because of course, this is y equals 0 here. This is y equals 1. This is y equals 1. This is y equals 2. Here's y equals -1. Then we have the point 1, 0. Well, here's where x equals 1. And 0 here, 4 here. So x equals 2 here. X equals 1 here. And we have the point where y equals 0. And then we have 2 more points in the graph. Looks like this. Okay. Now that looks something like the square root graph, but it isn't the square root graph. You remember the square root graph? Okay. We really haven't done the square root graph. It's an inverse of the squaring function. I'm going to show that in a minute and show that these things contrast. Okay. Now, the way this works, okay, here's the red dot. Okay. And I'm going to sketch a graph. I'll use blue without doing all the subdivisions and lining everything off. I think the graph looks about like this. Okay. Except I did a bonehead thing. I started right here in the lower left corner because I wasn't being careful. So let me see if I can make it look like that. Got to start close to that corner. Remember, we start just a little. What I'm drawing here should be the exponential function. This one. So let's draw it correctly. We start here. And looks something like this, right? Okay, I think I finally got it right. Okay, now I'm going to draw the graph for the inverse function. This rectangle is going to share the red dot because the red dot is at the origin. But this graph is going to be down like here. It's going to go up to here and it's going to do this. Now, whether you do this on the grid, it's been constructed the way we do it in the pre-calculus section, or some other way. Graphs are going to look like this. To be sure we understand, up here's some y equals 4. Here's for x equals 0. Here's for y equals 0. Y equals 2 up here. Y equals -2 down here. So where is y equals 2? It's halfway between 0 and 4, right? Well, here's y equals 2, and it does appear to be about halfway between here again. One of my rectangles is bigger than the other, so they should have been the same size. X equals 4 out here. X equals 2 here. If these rectangles have the right size, if I draw this diagonal line, which is supposed to have gone through this point and we missed it. Let's see if we can do that there. Any half conscious 4-year-old would have done better than I did. Let's see if I can improve it a little bit. I'm going to let it dry for a minute. But that line should have gone through this point and this point. So I'm going to draw from here. See if I can get myself in the right position to see where it's supposed to go. Now, it's still a little bit low. But what I'm going to say is every point on this graph It'd be connected to a point in this graph by a straight line. And if the graphs are constructed correctly, you see that this rectangle is a little wide this way. This point should have really been back here. If it was constructed really well, this line would be perpendicular to this line. And this line would bisect this line segment. In other words, it'd have equal distances on both sides. Okay. If I take a point here, conditions chalk, a little bit of constructed, but there we go. Okay. I can pair up the points because the x coordinates of the inverse function are the y coordinates of the original function. Now, since you've switched the x and y coordinates, all this is going to be true. Okay, well, that's fine. That's how you split the graph. Just quickly, if I do the same thing with squaring function, I'm not going to draw all the construction lines and everything. Apparently not going to go up very well either, but here we go. Okay, there's a squaring function, right? You can do all the construction, or if you're in the distance section, you can do it with a grid. A lot of people construct a grid, but I don't require that because people in the distance section could be taking a different section, which is not required. But, right there it is. And forget that. Now you could make the table and then you could reverse the table, right? If you do, you're going to find that again, it's the y values will go from 1 to 2, and the x values will go from 0 to 4. And if you do that carefully, I get something that looks a whole lot like this. Okay. So what we have here is called the inverse relation for the squaring function. It's not an inverse function. Why is this not a function? Somebody tell me why it's not a function. Just putting you on the spot a little bit. If you can't answer, it's okay. I'll remind you.
There's no.
Okay, so we put a couple of numbers on this. Yeah, just one number. X equals 2, right? Here's the line x equals 2. Now, how do you estimate the value of this curve when x equals 2? Well, you go along the line x equals 2 until you hit the curve and figure out what the y value is. Okay? You know how to do that. The problem is, if you go along this x equals 2 line, you hit the thing twice, so you have two answers for what's the y value, right? Okay? So when x equals 2, we find two y values. All right. So we have to reconcile that. Well, what we do is we say, okay, let's see, these y values down here. I mean, here's the line x equals 0 because there's a red dot, right? I said y equals 0. Y equals 0 here. all these y values would be negative, right? Throw out, yeah, let's throw them out. Throw out the negative y values. Okay, am I going to throw them out? They're gone. I just wavy lined them out. Okay, and what's left is our inverse function. Here's our inverse function, and here is discarded branch of the inverse relation. Okay, we have to discard it because we want a function. We want something that we can put into our calculator, or do a Taylor series expansion on, and you would do that. And approximate, okay? Now, I would further say, if we want to get the inverse function, we look at the fact that this function isn't one-to-one. And what we actually do is we throw out this part of the function so that we don't have to cross out this part. And we just invert this. Okay. So that's often kind of a mystery, but it's kind of easy to understand if you look at the graphs. Okay. You didn't have to do that with the exponential function because it's one-to-one. Now, what does one-to-one mean? That means for every horizontal line, you only hit the graph once. And that's what I think you were signaling there, unless you were trying to land a helicopter or something. Okay. So this is not one-to-one. So if you start with a one-to-one function and you want to do the inverse, you pick a branch to throw out. And we say you restrict the domain of the squared function in this case to values from 0, values that aren't negative. Just throw out the part with the negative values and you get a perfectly good function. And what's the inverse function of the square root function? Well, the square root function is f of x equals x squared. The inverse function is f inverse of x equals the square root of x. Okay. Now let's look at a really simple property of inverse functions. F of x equals x squared. Its inverse function is equal to the square root of x. And it only works when x is greater than or equal to 0, because we know we can't take the square root of a negative. There's no negative number that you can square and get a positive. Okay. So take that and use your skill with composite functions. Here's your definition of f of x. Here's your definition of f inverse of x. Do the usual thing with composite functions. Tell me what f of f inverse of x would give you. Okay, everybody is trying to do too much at one step. And which is why I say follow the steps. So really get used to the steps. And tell you, some people wrote down the correct answer, but no steps. Some people wrote some steps, but didn't quite get it right. Okay. F of F inverse of X. Look at the definition. What has replaced X? What is it that replaced X? It's F inverse of X, right? X has been replaced by the expression F inverse of X. So you replace this X with the expression F inverse of X. I urge you to always write that step. Okay. It's easy to get into your homework and kind of remember how it goes and get the right answers. If you're not writing out the steps, it's going to have a strong tendency to get away from you when you really need it. Okay. So we always, and review your notes, you've always seemed to do it like this. Okay. So make sure you're always doing it like this. And then, well, now we know what F inverse of X is. It's the square root of X. Of course, that gets squared. And what's the square root of X? Squared. It equals X. So actually, everybody did make a little bit of a mistake. Okay. Do all the steps. And you won't make mistakes, especially if you've done these steps step by step. Okay. And this is really important. It's a big stumbling block in this course. Okay. There's a good chance, you know, you all are bright students. There's a good chance you're going to have a couple in the future. Okay. Now there's a little glitch here because this really isn't true. If the square root of X squared equals X, then what's the square root of -5 squared equal to? It's equal to -5. Okay. But you're not going to put a negative in under the radical. Okay. Is it a problem? No. The square root of X doesn't accept the negative number. Okay. But that's something you kind of got to watch for. If you look up here, this F inverse of X is the square root of X. But X is required to be positive or non-negative. X is required to be greater than 0. Okay. So another way of saying it is we already excluded negative numbers from here, so this isn't an issue. Okay. Okay, so we're all right. Except we're gonna have to then say the domain. is at 0 infinity. Because what do you do if you do f of f inverse of x? First thing that happens is the value of x goes into the f inverse function, right? So the value of x is going to go into the square root. And if it's negative, you're done. It can't be. Okay? So there's the reason negative numbers are excluded from the square root. They can't go in here. And also, a number that gives you a number here that won't go in here would have to be excluded. Of course, any number will go in here. You can square any number. Okay. So that's all important stuff when you're dealing with inverse functions. Now, let's switch over to little algebra. Suppose y is a simple function, 3x plus x. It's a linear function. And next week we'll be starting on linear functions, okay? But you should kind of be familiar with it. You seem to have a pretty good background. Everybody in this continuing distance students have a pretty good background. Okay. Well, if y equals this, what's the inverse function? Well, let's leave the f of x off and just write, well, y equals 3x plus 6. Is a function. What did we do over here to construct a graph of an inverse? We swap x and y. You know, we made our x column into our y column and our y column into our x column. We had x equals 3y plus 6. Can you solve this for y? Okay, so you solve this for y. Everybody got it. You subtract 6 from both sides, then divide both sides by 3. You get y equals x minus 6 over 3. Well, from that, how is an f inverse of x? Is x minus 6 over 3. Okay. Now let's verify that this is an inverse. Here's your f of x. Here's your f inverse of x. Find f of f inverse of x. Follow the steps. Okay. Place x with f inverse of x and go from there. Okay, so f of f inverse of x equals what? Well, you've got to take f inverse of x and replace x here. And that gives you f of f inverse of x. So you also have to replace this x with the expression f inverse of x. So that's 3 f inverse of x plus 6. You always want to do that. The next 100 composites you look at, do this. Don't think you know where it's going. Okay. chances are good that with a little practice you do, but make yourself write the steps because they're short. Okay, if you get one with big, long, ugly expression, if you've done a bunch of shorter ones, you'll kind of know what to do, and you can maybe skip some steps. But for short expressions like this, don't skip steps. Okay, so anyhow, so we've substituted f inverse of x for x in this expression, right? And we get this. This expression is so, then this has to be so. Well, now we said that f inverse of x was x minus 6 over 3. So instead of f inverse of x, we're going to write x minus 6 over 3. Now, people have trouble with this algebra. We're multiplying by a fraction. So we could write this as 3 over 1 times x minus 6 over 3 plus 6. Okay, so how do we multiply fractions? We multiply the numerators and we multiply the denominators. So we're going to get 3 times the quantity x minus 6 over 1 times 3, which is just 3. Okay. Of course, that's just the same as 3 over 3 times x minus 6, isn't it? Three over 3 is 1. We have 1 times x minus 6 over 1. That just gives us x minus 6, right? Now, what's this? How does that simplify? How do people get 9? Can't get 9 out of that. Don't think so. I think so. What do you get when you add negative 6 to 6? Negative 6 and 6 is, yeah, thank you. Okay. Half of you had it, and somebody's, I don't know. Having a bad run of perceptions here for a minute, but that's not common. Okay. Make sense? That's equal to x. Okay, now open math will say, well, you just cancel this 3 with this 3. People don't understand rules for cancellation, so I don't like cancellation. It comes down to that 3 is going to end up in the numerator here. It's going to multiply the x minus 6. And this 3 is going to be in the denominator. Okay. So now you can factor or cancel a factor of the numerator with a factor of the denominator. Okay. It's the only cancellation rule. I think you need to know. You need to know more. But it gets a little confusing if you don't know this. Okay. So we don't really need to do this rearrangement. I've just kind of proven that this rearrangement works, right? This is why you can divide a factor of the denominator into a factor of the numerator. Now, the point is that this simple linear function was easily found the inverse, okay? Everybody found the inverse. Nobody had any trouble after switching the x and the y, getting the expression for the inverse. but then people have trouble simplifying. Okay, so you kind of want to focus on that. All right, make sure you know the rules. Okay, well, we're going to do one more since we've got about 9 minutes. I'm going to let you do it. Follow exactly the same process. Imitate every step that can be imitated. Meaning you always start by writing out. Well, you always start by writing out y equals. Well, you can always put a y equals there. So you have a y swap with the x. So what's the first thing we do? Write it out. Write the words. We've got 9 minutes. That's going to be enough time. Write the words. Swap x and y to get. And be in the habit of writing those words so you don't forget. Make your life much easier in the long run. Okay. The words I use here, not things logically. Use as many of them as you possibly can bring yourself to do. And if you think you have a better way of wording it, there are better ways. Sure. Okay, so far it looks pretty good. A little glitchy, but so what's the next thing we do? You're welcome. Y equals x over 3 plus 5 is our function. Swap x and y. We get x equals y over 5 plus 3. And then skipping a step, I do want you to write out the minus 3 on both sides. You're going to get y x minus 3 equals y over 5. And then you do what you always do when you have denominators. You clear them. You multiply everything on both sides by the denominator. You just multiply both sides of the equation by the denominator. And this gives you x minus 3 times 5 equals y, right? So y is f the inverse of that. And that is 5 times the quantity x minus 3. Okay. Get some hand signals. Okay, there's a little confusion because I didn't write this as clearly as I'd like. This is an equal sign. Somebody interpreted this as a -5 here. Okay. And if you did, that's fine. If you did the algebra correctly, the only difference is you're going to have a -5 here. Okay. And it's still going to work as long as you use your original function. Now, what's our last step? We find of f inverse of x. And that's equal to F inverse of x over 5 plus 3. Okay, we have to make that step. We replace this, both of these x's by F inverse of x, and there's no possible denying that this is what we get, assuming I copied it right. Okay. That's an easy step. You have to take that step. For a good little while, you want to take that step to make sure it's always with you. Okay, so we have F inverse of x. Well, F inverse of x is 5 times x minus 3 over 5. Well, F inverse of x is 5 times x minus 3, and that's over 5. So we write this, and then we have plus 3. What's that equal? Well, 5 divides 5, which is x minus 3 plus 3. Well, negative 3 and 3 adds up to 0. And that leaves us x. Okay. So here's our task. Always F of F inverse of x equals F inverse of F of x equals x. That's your test for whether you got the right inverse function. Okay. Yeah. Okay, just to put a point on this, because somebody just said this, so is that always going to equal x? I said, yep. And the reason is, how did you get your inverse function? You swapped x and y. Okay. Whether you did it with a table and a graph or with a function, it's going to have the same result. So here you swap x and y, but then you swap them back. Okay. So you're back to where you started from. So if you started with x, you're going to end up with x. X is going to become your y. But then when you apply the function, your y is going to go back to your x. It's a little hard to understand. You got to get your hands on it. So again, I emphasize, write out every step the way I've written them out until you understand it well enough. You do slightly different steps to do the same thing. And if you never get to do slightly different steps to do the same thing, it's okay. If you do these steps, it's going to reinforce it to the point where you understand it later when you need it. Like, you know, on the test. Okay. Okay, you did well. Do kind of focus a little bit on that simplification because people have a little trouble simplifying expressions.